I don't know how many of you know Jamie's work, but I think you're going to be amazed at what he does. I mean, I've known that his work, honestly, since I was in school at Columbia back in the mid-'80s. And at that time, I think you were known more as like a glass artist. I mean, you were working almost exclusively in glass and were just doing unbelievably beautiful work. And very focused and very passionate about light, about material effects, about the properties of glass. And it's really, I think, it certainly set the foundation, but it's driven Jamie's career throughout it. And now he's at a point where he's recently expanded his practice to kind of have an architecture practice and a kind of a specialty consultant practice. Is that
right?
And is doing, some of the most amazing work around the country and a lot of incredible work in New York. Two of the projects that I'm sure you'll show, but that resonate with me because I've spent a lot of time there. One is the Fulton Street subway station, which is in the downtown part of New York, kind of in the Wall Street area, where it's really it's referred to as the canyons of Wall Street because you just don't get much light down there. And this is a major transportation intersection and hub. And the architectural project was done by Grimshaw's office, and Jamie did this beautiful, I think it's called Skynet, and was able to somehow, almost magically bring in the most incredible quality of light, like essentially into the subway in one of the most densest parts of Manhattan. And it's, I don't know, it's that kind of sensibility and just attention to detail and just a kind of passion about light and the effects of light that really characterizes his work. I think it's also an interesting comparison, especially for you guys, because we have an interesting exhibition going on right now of Calatrava's work and he's speaking in a few weeks. And there's an interesting but parallel for me between Calatrava's work and Jamie's work. I mean, but on the one hand, it's quite different. I mean, they're both, you could say, driven by an interest in art, an interest in engineering, and an interest in architecture. But I think Calatrava's work, on the one hand, is very expressive of the physical. I mean, structurally, his work is unbelievable and very ambitious and very daring. And Jamie's work, I would say, is more on the kind of ephemeral and phenomenological effects of light and glass. So you think of steel and physical with Calatrava, and you think of kind of glass, effect, and phenomenology with Jamie's work. So it's an interesting comparison, for students to after you see this work, maybe go back and look at Calatrava's work and try to make sense of how they're different and how they're kind of related. So I won't go into any biographical information except to say that Jamie has went to undergrad in sculpture. Started in architecture, then switched over to sculpture, and then did work at Harvard GSD, and then started his practice, won many awards, including a MacArthur Award, which is one of the most prestigious awards you can get as a creative artist. So with that, please join me in welcoming James Carpenter.
Great. Thank you, Scott. Great. Thank you very much. And an afternoon lecture. It's always a good way to end the day. I'd just like to follow up a little bit on what Scott was describing relative to my background, because I think it's relatively important as a student to have an understanding that your professional trajectory may not be so precisely defined as you may think it is at the moment that you're here. But as Scott said, I started in architecture at the Rhode Island School of Design in the late 60s. And perhaps in some ways, in a sort of a miniature way to this campus, we had, it was very much of an industrial design school. We had big machine shops and literally industrial scale textile mill on campus where students could be making thousands of yards of fabric if they chose to do, and foundry equipment. And it was very much of a 19th century industrial design school when I was there. And studying architecture within the first couple of years, you were always having to move through these different studios, and you're obviously interacting with students that were in some of these other programs. And I sort of realized that my interests in architecture were probably as much an interest in materials and engineering, and particularly light, than it was about some predetermined idea about what architecture was. So I sort of found myself moving away from the architecture program after a couple of years, and then moving into the sculpture department, where there was a very, very small glass program that I became very deeply involved in the machine shops. And then following the latter part of being at RISD, and just after that, my work as a sculptor was really, yes, working in glass, but it was also in film and photography and projections on glass and film projections in spaces. And I'll show you a couple of those projects. But it was all about how light, and I think of light as information, basically. Light is information. It's what's informing us about everything around ourselves. That light as a source of information is really what defines our experience in place. It's not just illuminating a wall surface or how light enters a building. It's actually the content of information in light that's informing our presence in an urban environment or a built environment. So our practice, or my practice, I was taught at Berkeley after going to RISD, and then I was hired, went back to Rhode Island School of Design and ran a natural history museum there. I should say, before I went to RISD, I was very involved in sort of chemistry. I was interested in chemistry, thought I might want to be a chemist, and then mostly related to like botany. And so I went to RISD. It was sort of focused on architecture, but I had actually paid for some of my education through doing botanical illustrations for various textbooks. So I was invited to come back to RISD and run a natural history museum, which I did for several years, and then worked for Corning Glass. And then towards the latter part of the 70s, I was doing artwork. And I sort of realized that I wanted to get back into architecture, and I'll sort of take you into that sort of description of how that happened. But light is really the underlying principle of everything I sort of work on. And it goes back to these projects, of which there's maybe about 20 or 25 of these done in the 70s, which are really film installations. And this is one shot in Puget Sound in Seattle. Small river, scaffolding built over the river, a series of 9 cameras photographing down into the surface of the river, capturing basically a migration of salmon, which were introduced to the river by the University of Washington. So this is actually where they did a lot of their genetic strain research on salmon. And a friend of mine was doing his PhD there, so we sort of did this sequence of films. And the idea was sort of film the actual migration. You alter the timing of the film slightly, meaning that you print multiple frame images, so it's slowed or a little bit more electric when you see the film projected. And then you reproject them on the floor of a museum or gallery. So you walk into the space, basically the river's flowing across the floor, the migration's happening in front of you. But by changing the timing of the film, and this is really critical to the way I think about things, changing the timing of the film, you actually see a different body of information within the film. So it's not necessarily just observing the fish and the movement of the fish through the water. It's the realization that you in fact are seeing a perfect reflected image of the sky overhead. You're seeing the content of information within the water itself, and you're obviously seeing information through the water at the bottom of the river itself. So in a lot of ways, these projects, and they're not all about fish, right? They're a lot dealt with bird migration and things of that sort, but they're all about how you could create spaces to have people experience a natural phenomenon in a very artificial environment, sort of in a gallery type environment. And after doing that through the 70s, the latter part of the 70s, early 80s, essentially the art world began to change quite a bit from my perspective, and moved away from more conceptual-based projects to more painting, sort of expressionist painting. And that's actually what triggered me to try to come back into architecture in some way. And this is a project done in the mid-'80s, about 10 years after that salmon migration film, but I just show it as a way of connecting earlier work to sort of the trajectory of work going forward. But it's basically commissioned by a family in California, which is a glass platform. The glass platform, here you go, the glass platform is floating over the river, and you actually access the bridge from either bank. So you you walk out onto the glass platform, you move on that glass platform, and then to the other side of the river. So the structure is essentially a device to slow you down and engage you more deeply in that particular ecology. So the way it functions, obviously sunlight hits the stream below it, bounces up, and then you get the caustic reflections on the glass surface, and then some very lightly coated glass that act as windows into different attributes of the surrounding landscape that you passed by. So it's actually trying to build something that in many ways carried forward some of the conceptual ideas of the art film installations, but they are physical structures that can be experienced, by an audience, any audience, not necessarily a preconditioned audience that goes to a gallery or museum. So those types of projects, were also happening in other ways at the same time, like how this is an early project done with Ed Barnes for a chapel in Indianapolis. And again, it's trying to think about cinema and what cinema means. I mean, what does this activation of light information surrounding us mean? And how do you capture it? And how do you represent it? And this is a fairly simple project. I mean, we're asked to do, there's actually 2 of these windows in this chapel, and the client essentially just wanted a totally clear window. They wanted to be able to sit in this chapel. It's part of a seminary. Sit in the chapel and look out over this beautiful landscape. So there's nothing around except this beautiful valley and nature. So when you're in here, you can look out. So it sort of left you with this idea, well, what am I being asked to do? They want a clear window, but how do you sort of engage with nature in a different way? It's not something beyond you at the distance, separated by a glass membrane, but how do you use the window here as more of a device or instrument that will transform that information and present it in a very different way, but in a way that perhaps helps you understand the exterior environment more, perhaps more intuitively and perhaps a little bit more deeply, simply from the point of view that if you have activity outside, like you have clouds moving overhead, or in the summer when there's leaves out here, you actually see the cloud moving across this field, or birds moving. And then this whole lower area, you get the vibration of the leaves and the trees. So it's basically taking attributes of the external environment, they're being completely transformed by this device and represented to you. So you're sitting in a space for a period of time, you have the ability to sort of observe that abstraction, and from it sort of derive a different connection to what's going on beyond this building. So something of importance, I guess, in many of the projects is this idea that the window is not just a single piece of glass, but the window is really this aperture that has dimensionality to it. It's basically a interstitial space between interior and exterior, and within that interstitial space, you can in fact create a differentiation between interior space and exterior space. My feeling is that when you simply have a piece of clear glass, you're observing nature, but it's always sort of held away from you. It's just kept at a distance. It's observing something like looking at a page in a book. You're not engaged with it. And this is trying to think of a way where the windows, in fact, are drawing you into that experience, and then perhaps even taking over the space you're in. So you're part of something that's much bigger than just your abstract idea of engaging with the exterior. So a lot of projects try to explore ideas like that, and we do a lot of work with architects, other friends who are architects. This is with Vince James up in Minneapolis, and it's a house that we worked on together for a couple, an elderly couple, who lived outside the city of Minneapolis, had a great art collection, moved into the city, bought 2 properties, tore down the properties, and then wanted to have a house surrounded by their artwork outside in the yards, and have a way of having very, very controlled privacy. So we designed a whole window system that allows you to close or change the view angles of all the windows in the house. So you could always look in a particular direction, and you really had no sense of neighboring buildings, with the exception of one window, and I just wanted to bring this particular window up as a means of exploring an idea that may make you think about some other opportunities. But the house is in fact in a neighborhood, so immediately adjacent to the house are other buildings, but you don't really ever see them from the house. And this one window in particular, which is diagrammed down below there, was quite significant. It's about 12 feet high and about 10 feet wide. And it separated their living quarters from the downstairs space. But if you imagine that window being here, the building or the house adjacent was only about 8 feet away from the window. So it's basically a window with no view. That's not an uncommon problem, right? That there are windows, probably half the windows in the world, if not more, have no view. But this is a way of like, how can you construct a reality that is outside, but it's not represented by a conventional window. So very simple device optically. Like if you imagine that being the sky directly overhead, just a simple series of mirrors at slightly different angles, like a periscope, lenses in front of those mirrors, and then a sheet of diffused glass, much like in a big view camera. So the information outside from directly overhead is brought down to the window plane. The lenses capture that information, they project it against the windows. So you end up with quite a interesting event that happens. Like here you have it, there's a stone wall, fence, garage, that's right outside the window. This is during construction, so you can see the mirrors are slightly different angles. That's the exterior of the window, and that's what you have on the interior. So each of these is essentially like a video monitor. It's about a 18-inch square image of a tree in the distance, the top of a tree in the distance, and then simultaneously you're getting sun passing through that tree, and it's projecting shadows of that treetop on the same window surface. So it's a window that's sort of looking at the exterior environment in multiple scales simultaneously, and it's collecting information outside that is that environment, but not an environment you would see if it was a conventional window. So it's simply, I think, an idea that working on smaller scale projects like this, this is one window that we did within the whole house project, but taking a small project like this, you can actually explore an idea that obviously has an unlimited number of permutations, if you just think about the principle, that you can actually create environments in a space that has no visible environment or no recognizable environment outside of it. And it functions at all different times of day and night because it has the woman, the wife of the family, always writes to me once a year about things that she's seen in the window. And one that keeps repeating in her notes is in the wintertime when there's no leaves outside and you have a full moon, you basically have an image of 80 moons projected on the inside surface. So it's just by way of saying, in the images I'm showing you, you're just seeing a moment in time. And these things have a completely different life at other times. There's really no way to properly explain them because they have a different life that might be more acute in terms of its informational content in one moment than it is another moment. So they have that life, which I think is part and parcel of light and part and parcel of our own experience in nature. And then taking these things, like to other scales. I just put this one in because it's a periscope. It's a periscope on a much different scale. But this is in a building called the Hearst Building in New York City, working with Foster's office. And it's a project which is taking the original Hearst headquarters building, like 1928 building. They'd thought they were going to build a tower back at that time, but during the crash, the original early depression, 20s depression, they never did it. So this always existed as this sort of podium-sized building, and they commissioned Foster, who gutted out the interior of that building, put up that whole new tower that you see in the background. But it left you with this historically important base that has a very, very tiny entry. So the issue was really how do people enter into a grand new building, have a sense of sort of the scale of that new building, and how would you actually overcome what's the most common problem with buildings is that if you're standing in the street, you're obviously in bright sunlight. Looking into a building can never be as bright as the street. So whenever you look at a building, it's always a darker environment. So what the principle started with this idea that the towers rises up, they actually incorporate these large clerestory windows and glass skylights that separate the tower from this older skin. So you have a lot of daylight coming into this upper floor, the third floor, which is actually where the new elevator lobby is. And And then how do you manage that light? And what you're looking at is from the street looking into the building. But what you're looking at, and I'll explain it to you here in a moment, what you're looking at is actually the sky outside. So if you're standing here, you look into the building, here's your periscope, not quite 45 degrees, but this is just, imagine this being a mirror. And then what you're looking at is, in fact, looking out these clerestory windows or looking up into this bright environment. So the light level here presented to your eye is the same as the light level out on the street. So you're basically balancing light levels so that the building has a sense of like sort of grandeur and sort of openness and draws you into it. So it functions, and I'll show you what they are. They're prisms, actually. And then simultaneously, we're taking the rainwater, capturing the rainwater on top of the building, which is something you have to do in most urban environments these days. You have to keep the rainwater of your building footprint on the property. And we take that rainwater down from the top of the building, and then we store it and filter it and then chill it. And it basically runs over this surface, and it's the cooling system for the atrium space from, say, April through November when you need that. So that's actually chilled water. It's about 38 degrees, so it dehumidifies the space. The humidity in the air condenses on the cold water, and it creates some sort of convection system on the inside. So it's sort of a visual element as, say, artwork, but it's also a performative element relative to the cooling functions of the building. And the way we do these things, we're very involved, Scott mentioned it, we're very involved in sort of the engineering and the materials and how you make the materials. So to do a project like this, this is a mold, this is one of the molds for it. It's just machined out of graphite, and it has a sliding end elements in the mold. And what you'll see, the glass is poured into this. And you use graphite because graphite holds the heat. It conducts heat very well, but it holds the heat very well. And the glass will not stick to it. So actually pouring the glass in, this is from a furnace that's overhead. Molten glass goes down into the mold. They weigh about 160 pounds each. And the one thing you can do when you're molding the glass is that all the construction details for how the glass is held, how it's sealed, how it's handled, it's all sort of put into the casting to begin with. So when you do the installation, it's really just a matter of having set out the stainless steel structure. The blocks just sit on the ends, and they span that length. It's about 5 feet. And cast glass is extremely strong. They'll hold about 6,000 pounds if you were to step on the middle of it. It's very, very strong as a single element. But it just allows that to float, and what you're looking at, it's clear glass. It's totally clear. There's no reflective coatings or anything like that. It's just clear glass, and by the optics of that prism, the light goes into the glass, and then due to the indices of refraction of the glass and the air behind it, the light actually hits the inside surface of the glass prism and then projects back out to your eye. So the light sees the clear glass as a mirror, just due to the angle of it. So here you have it. It's just that you're looking into the building, but you're just taking all that sky brightness and projecting it to your eye. So it's fundamentally the same brightness as out of the skylight. And you move up through it as a way of, I think, sort of changing people's experience. And when you walk in the building every morning, this water's rushing over the surface. It's part of the cooling environment, and it's an event that everybody shares coming into a building. And a building like this has a population of about 3,800 to 4,000 people, so it's quite a few people moving through it. Sort of at a similar scale is this building with Skidmore, and then on projects like this, it's a building which came down obviously in 9/11. This is World Trade Center Tower 7. It came down the afternoon in 9/11, and it had a power substation in the base of it, the original building. And therefore, Lower Manhattan was sort of out of power for quite a long time, for almost a year. And they just used sort of small sort of trailer truck-sized transformer vaults, spread around the area in the interim period until this could get built. And what you're looking at is the lower 6 floors of the building, and this is a good 2 years after the tower came down. But we were involved. Got introduced to the project by Skidmore, but as is often the case, we actually work directly for the client. So we're working sort of in parallel with the architect. in this case, and then we have a charge of like dealing with the exterior envelope, like what are we going to do with the exterior envelope, and how is it going to be in this particular building, how is this building going to represent a level of construction and detailing that the owner wanted to communicate to the public as an example of what he would do with the remainder of the site relative to the types of buildings. So the first instance was, this is basically a power substation owned by Con Edison, our power company in New York, and then the commercial tower takes off up above. The lobby is really fit between a north and a south transformer vault. So the building was really an exercise in how you got maximum height for the tower within a fairly confined lobby space and then accommodate those vaults. But since it is like this 6-story high vault concrete space, the drawing you're looking at is really a drawing trying to understand where the sources of available daylight are in downtown Manhattan within a fairly small, narrow streets. This is not all the way downtown where you have sort of medieval Dutch grid, but sort of just above that, the narrow streets are still relatively narrow. But in that instance, your sources of light are not from across the street. They're generally from down the streets. Like the light sources are down the street. If you look up, you see the sky. Or if there's some holes in the sky plane opposite, you'll have areas of light available. So this is a diagram of essentially what light you might be able to find if you imagine this surface being made out of, which it is made out of stainless steel. They're like extruded equilateral prisms. And if you just took the surface of that prism and you rotated it slightly, basically what's happening, the prism is seeing the light that's oblique to the face of the building. That light is being registered on this surface, and then you're looking at it from that angle. So this whole bay would be tilted at a certain angle to gather that field of light. Or these would be tilted at other angles, either direction. But it's basically just how you would program the skin of the building to capture available light. At each elevation, you do the same thing. Try to figure out where the sources of light are. And then that's transferred into, like, now how do we do that? You have sort of the idea of what it should be in principle. And then we ended up working with a company in Minneapolis that does mining equipment and oil field equipment. And they make they actually make gratings or screens for filtering slurry and liquids to separate particles from liquid bodies. So we built a system using their machinery, scaling up their product to the scale we needed for this building to produce these panels that are actually 50% open, meaning that this wall is actually open. If you walked up to this, you could look through it. Because there are those transformers inside, they're generating an enormous amount of heat. They need to have natural ventilation. So this is basically a ventilation system for the transformers behind it. However, because we all knew at the time that this part of downtown would eventually get developed, it was still like a big smoldering pit, basically, when we were doing some of the early work here. But you knew that there was never going to be another super block element the way there was in the original World Trade Center site, where you had just this, almost 4-city block area that was up on a raised podium and very impervious to pedestrian activity. You now had all the streets being reopened down at grade level. So what is this base of a building? It's a power substation. So what would you do to sort of aesthetically or visually make it something that engages with individuals, that are right up against it, or you're seeing it from several blocks away? So it has a level of tactility and refinement to it that's rather unusual on a building of this size. And then secondarily at night, there's a second layer of finer prisms inside. And what you're looking at is you're looking through that outer skin that I just explained is 50% open. So this is the proof of the pudding. You're looking through the outer skin, seeing an illuminated surface inside. And the whole principle is daytime, the surface quality of that prism is such that your eye stops at that surface. Your eye doesn't challenge the surface it's reading. It doesn't try to look behind that brighter surface. And then the surface quality on that stainless steel is, it's not a polish, because you don't want something that's highly reflective, because reflectivity simply means that you either have a maximum presence of light or a complete absence of light. So reflectivity has a very double-edged life to it. It can be totally black or totally light. But if you take the surface down slightly below a polish, the light actually resides on the surface. The light will remain on the surface. It is reflective, yes, but it's scattering the light, and it sort of stays in that surface, and your eye will never look through it. So daytime is that image I showed you before. You read it as a solid surface. Nighttime, we illuminate the inside surface, so your eye stops at that inner layer, and you don't ever look through this to the machinery behind it. That's the whole idea. You're just playing with how your eye functions, like your eye won't challenge itself to look beyond that surface. And in these types of projects, you can sort of see the base of the building, and the tower was trying to carry forward this whole idea of how you work with light, and I'll explain that. But this is the base of the building, and then there are moments in the evening when it goes into more of a color, like a sort of a blue color phase, and it goes back to a very simple white phase. But that's looking up the corner of the tower. And then the curtain wall is, the idea here is that we have beautiful light. I mean, you seem to have very beautiful light here. I don't know all the sort of geological and sort of topographical conditions you have here, but in New York, we're obviously surrounded by rivers and water, and therefore you have a lot of water vapor in the air. Not necessarily fog, but just microscopic particles of water in the air all the time, and therefore the light always takes on a more physical presence, and it becomes more tangible oftentimes. So we wanted the building to be able to capture qualities of light and be highly responsive to those changes of light that we have, so that this particular building would have a level of responsiveness to its environment that other buildings don't have. And the whole design basically is based on this idea of the spandrel section of the building, which you see here. Where all the primary structure for the building is: floor slab up above, main steel structure, services below it, and then the ceiling of the floor below. So the glass panels basically start at the head condition. They're double glazed units, of course. They come down, they go right past the floor slab, and then they overhang the spandrel. So the glass panels are basically hanging and terminating in air over the spandrel, and then by slightly curving this panel at the back, and it's slightly corrugated, and introducing a reflector, there's actually a reflector built into the sill, you sort of get this happening, which is, if you did nothing to that surface, obviously the sunlight's hitting the top, and you're seeing shadow underneath. I mean, it's obviously corrugated, so it's going to be bright, dark, bright, dark, bright, dark. But if you introduce a reflector, and it doesn't have to be direct light, it can just be sky brightness, you're actually bouncing blue light back into the shadow. So the whole idea here is that when you're on the street looking up, you don't sense that it's blue, but it is blue. You actually have blue light pushed up into that cavity space. And the whole concept there, there's some diagrams of how it works. The whole concept there is that this reflector works at all different times of the day in many different ways. On an overcast day, it gives you the sense of depth behind the glass. The corners are sort of exposed. You sort of see a person standing up there, sort of exposed. So they look like sort of glass trays stacked. Or occasionally they catch the light and sort of turn into that whole field of daylighting reflectors. And this is coming back to something I maybe didn't explain earlier, but the blue light, anyway, I was just explaining this in this section of the building. What happens is that it occasionally merges with the blue of the surrounding sky behind the building. So oftentimes you'll get this idea that the blue sky of the sky itself is slipping behind the glass and then reappearing at the other side. So it just feels like these glass cassettes stacked up. But I think more importantly, it's just something that I should mention, because it's in all of the projects in different ways, is that when you look at light in nature, I mean, if we just step outside this building and you just look across the yard, you're basically seeing millions of surfaces simultaneously that are all illuminated in slightly different ways, right? All the bark, texture, leaves, everything there. So your eye is actually taking literally billions of pieces of information and constructing a highly simplified but sophisticated understanding of what's in front of us. And I sort of very strongly adhere to this idea that we respond to light as a volumetric phenomenon, that you need that light happening in multiple surfaces simultaneously to sort of activate your vision and sort of engage you with the multiplicity of sources of light that we're always seeing around us. So just by very simply saying that you have one element of light on the surface of the glass, and then behind it you have other multiple qualities of light behind it. So you're always juxtaposing several events of light overlaid on each other. So you read something that's much more engaging and I think a little bit more challenging relative to informing us of what's around us. And you might just compare that to, if you looked at that Hearst fountain, if you just imagine what that is, those are prisms. I mean, in cross-section, they're maybe that size as a prism. You have the sunlight coming in, you have water running over the surface, so the light's actually passing through the water, passing through the glass again, passing through the water. So that light has actually been activated by those multiple surfaces that it's passing through before it actually arrives at your eye. And you're getting multiple levels, front surface reflection, secondary surface, tertiary, all these different levels of light that are behaving sort of in concert with each other to inform you of what that event is. So it's something that we try to think about on projects, and obviously every project is different and it has different challenges, but also has different opportunities. And this is quite a different project for the University of Chicago, which is this is the original Olmsted plan for the 1893 World's Fair, which took place here. This eventually became the North Campus for the University of Chicago. That's the South Campus. So here you have the hospitals, the labs, main sort of academic quad here, and then the beginning of what has always been there, but sort of an undeveloped South Campus. There's now a very beautiful Todd and Billy Chen building there, and some other buildings that are going up to sort of build this up. But this landscape, which is an Olmsted landscape, although it's really a World's Fair site, is a little bit, let's say, under-maintained and sort of overlooked, and it had always had a history of being somewhat dangerous in terms of students' activities moving across here. It's about 900 feet across, so it's not insignificant in its width. And we were asked, after actually giving a lecture there about light in the physics department, to think of some ideas that we might do to integrate these two sides of the campus. So these are some towers, lighting towers that we developed, and they're made with a machine that it's like a lathe that has these splines, and they're turning, and then you basically weld a continuous stainless steel wrap all the way up. So they're about 40 feet tall, and they have a single source of light at the base of them, but they're meant to be sort of extensions of the street wall from the North Campus to the South Campus, and also involved changing all the sidewalks and introducing more landscape, and then trying to resurrect an idea from Olmsted's plan that these were to be bridges over a waterway. On that original plan I showed you, he wanted to join Lake Michigan to Jefferson Park, which is at the other side. So he imagined that being a water area with bridges. So these are bridges in a visual sense. They're not technically structurally bridges, but widening them so students have a place to gather and interact and look at intramural sports that happens down there. And then they all have different qualities. So trying to remove lighting, we tried to remove as much of the DOT lighting as possible because we replaced the required amounts that they need to have. But they're trying to work on a very different idea of light, which is we have such a convention of just assuming light sources are on a pole and they're overhead. It's like literally goes back to day one of the invention of the light bulb, or even gaslight, where the gaslight is just an abstract representation of the source of the sun overhead. But it's a very, very inefficient way to light anything because all the light you're generating is falling on asphalt or grass. It's falling onto absorbent surfaces, and you're losing the majority of the light you're producing. So this idea is really a type of light which is radiating horizontally. So it sort of comes out equally horizontally. So it's a single source down here that one guy can change. projects the light up. There's a mirror on the top, and it bounces the light back down. So the light is basically just captured inside this stainless steel tube. And it's effectively equal to, say, moonlight. That gives you a fairly good connection to that level of light. So it's that type of light. We definitely use way more light than we need. And we've sort of ratcheted ourselves up to the point where we think we need all this light, but you really don't need as much light as we do. But what this does in terms of these walkways is that you can sort of see the next one in the distance. There are actually 4 of them. They're about a mile long, so it's another way of metering the landscape when you're walking. You sort of gauge some distances between things. And this is a project in Israel. Again, lighting on a different scale, a different type of environment. Israel Museum, which is in Jerusalem. A beautiful garden by Isamu Noguchi here with a lot of very good work by Terrell and Sarah and others. And this is a building by Frederick Kiesler that houses all the Dead Sea Scrolls. And we were asked to sort of look at the campus, which was built in 1964, and try to think about how we can improve the visitor experience arriving there and basically sort of clean up the campus. And you can sort of see there was a road running right through the center of the campus. They had trash pickup in the middle of the campus, always sort of separating these parts. So one of the main things we did was taking down these buildings and adding a couple of buildings. We eventually took down 5 buildings and added 5 buildings, but new bookstore, security, restaurants, and then a big service building underneath here, which are outside of the actual museum grounds so that they can be open at any time. And then taking out that roadway, but creating an underground passage. There's a 60-foot elevation difference between here and the upper part of the campus, so we're on a hill. And we had to regrade all of the landscape to sort of make it meet current ADA accessibility. But we, most importantly, sort of put a whole tunnel underground in a new building at the center of the campus right here for new entry into the building. So that's sort of the scope of work. It's about 90,000 square feet of renovation, about 100,000 feet of new construction. And the interesting part of the project was going in and carving through the center of the campus to get rid of that road, to provide all new services into the core of the campus, and then this below ground walkway. So this is actually the passageway that's in that lower excavation you just saw. So you're moving up about 100 yards, a little over 100 yards through the campus. At the beginning, you're about 18 feet below ground, and up here you're about 60 feet below ground. And the whole goal was to have qualities of daylight that would be even, or you would perceive them as being even as you walked up the space and felt always connected to the landscape, even though you're far below the landscape. So there's sort of courtyards that are the fire exits that are planted. They bring down light and greenery at different strategic points. You come up into this end piece by Olafur Elias, and then you come into the new upper building. But there was the original buildings had this really wonderful intimacy and scale with the landscape, which is something we lose sight of. I think a lot of buildings start getting out of scale oftentimes. But this is a little bit what we were trying to get at, the scale of a building in relationship to the landscape. And these are the original buildings. They're all concrete boxes. All 4 walls are poured concrete with a limestone cladding. And then the way they dealt with the intensity of the light was literally just this little gun slot window, east, west, and south, and then a larger window to the north. But the roof is independent of the walls. There's a central column and a hyperbolic paraboloid roof that sort of sits separately from the walls, and that infill is basically the glass. So their approach to dealing with the intense light is reduce the window aperture to a very, very small area, and then use a darker glass. And those are fundamentally the same principles that are generally used today when working in these environments. You have smaller window apertures or a very, very high performance glass, usually very highly reflective, highly absorptive, to cut down on the thermal gain from the sun. And we sort of took a very different approach. where we wanted the buildings to be scaled similarly to those smaller buildings we just showed you, but we wanted the buildings to actually be all made out of glass because, as you can imagine, the original buildings, which are all concrete, are totally opaque. You never knew if the museum was open. You never knew if there was any activity in the museums. So they're basically mute cluster of structures on a hill. So our whole principle here is glass skin, floor-to-ceiling glass, and then outboard a shading system which keeps out 100% of direct light every day of the year. So there are no times when direct sun gets into these buildings, and therefore you can use, actually just using laminated glass, it's not even insulated glass, just clear laminated glass, fully shaded, and you can reduce the mechanical systems by about 40%. Because they're always in shadow, or always in shade. And we designed two louvers, sort of this one and this one. This is one for the east-west elevations. Because we're on a hill, you have light coming in horizontally. So you have to keep out almost has to be opaque, let's say, to the sun. And then a north-south louver, which as the sun angle's fairly high around noontime, you can actually have the louvers spread apart so you can look through them. So they're extruded terracotta elements, but here's the principle. Like exterior surface, all that intense light is hitting this louver or this foil. The light hits this cove and that's bounced up, as you can sort of see in any one of these studies. So it's a shading device from this side, but using that portion of light projected back on the inside surface of the same piece. It's actually the lighting system for the building. So it's a shading device from the exterior, but a lighting device from the interior. And this is in our office in New York. Like imagine the exterior surface, you just see that little cove in the ceramic. The light hits that, and then that light washes that upper surface above it. And what's of interest is you get color of trees, color of people outside, you get shadows, leaf shadows. So that surface, even though it's technically opaque to view, again has another whole field of exterior information brought to the interior in a fairly abstracted way, but nonetheless you have a connectivity to nature beyond it. And this is just the production of those pieces. That's what they look like. They're sort of hollow terracotta extrusions. And then on the north-south, they actually, the exterior, they capture shadow, and they're very open. So this is the north-south axes of the main entry. So they're always transparent when you walk up or back down, and then they're opaque from the east and west elevations. So all the walking circulation is kept in these shaded environments. And then this is the system. So that's your lighter one, that's your floor-to-ceiling glass system. And they allow you to have sort of a very interesting connection to the surrounding landscape. And again, the scale of these buildings is fairly modest, and they sit well within that original complex. So all of the shading trellises are also made out of terracotta. And working in Israel, it's a little bit, you have to be careful because they're not actually at a level of construction technology that we would expect to find here. So it's a very simple palette. It's just some poured in place concrete, a lot of precast concrete, terracotta, and then a glass system done by a company in Turkey. So it's like very economical project. And took about 4 or 5 years to do that project. I'm just going to take you through a couple last little projects here. There we go. And that's that walk that you now have to go. So that tunnel photograph I showed you, you're about 60 feet below this point. You're down in here somewhere, below ground. With the light coming into it. And then a project with Michael van Valkenburg in St. Louis, which is the Arch Grounds, a competition that we won together quite some time ago. It's under construction now. But the idea is our part is renovating the existing Saarinen building, which is under the arch. It's a little museum building that's terribly run down, and then doubling the size of it and adding a new entry. So the issue was the original entries to the museum were at the feet of the arch. So you'd enter and exit at the base of the arch, but you would never actually have a sense of that from downtown. So we're actually covering a highway that's already done, separated it. So now the landscape to a new entry, and it leads you down. Here's an early model of it, and sort of some of the construction of it now. So that's the Sardin building, which has already been uncovered, re-waterproofed, being reburied, and then the new addition, the new entry, which will eventually all be covered over as well. And just a very simple arch glass, or relating a little bit to the shape of the arch itself, but just in the reflectivity of the sky as part of the entry. And then the view back towards this famous courthouse, which always was separated again by the highway. It's there. So this is opens next year, next summer. And then the project that Scott mentioned at the opening, this is the Fulton Center here, which is Broadway. And the building we looked at before is this building, which when it was built looked really big. Now it looks really little. We thought it was a big building. And this is a project with Arup is the lead on it, and then Grimshaw is architect working under Arup. And then we are actually contracted by the Metropolitan Transit Authority to work on the daylight, and working with both Arup and Grimshaw, which we do on many programs. We're collaborating with people all the time on our projects, but work with both of them on the sort of daylighting effect. But the project actually is probably 80% of the project is underground, in terms of budget, all the new tunnels and all that. So the piece above ground is a fairly modest part of the project. And this is the design. We went through a couple different designs for it, but this is the final shape, which is, as you can sort of see, it's a sort of a modified toroidal section. And the scale, just in comparison to the lobby of the Guggenheim, is coincidentally about the exact same size. But the intent here, and another reason we put it on top of the Guggenheim image, is that by curving these surfaces the way you see, when you're in the space, looking at this curve, you are looking through the skylight, but in fact you're looking way beyond the building. It's not like your view is stopped there. You're actually looking all the way over beyond it. So it's actually a device that broadens the image of the sky that you have because of the geometry. And then these are some early models, and we obviously go through all the analytical work and structural work. We work pretty much with one engineer and have done so for 35 years, which is called Schleich Bergerman and Partners from Stuttgart. They're real cable specialists. And we do our own daylighting analysis work. And these are just studies of like what the shape of it needed to be to accomplish what we wanted. So breaking down some of the studies and models. This is like a little fragment of that. Not easy to do, a fragment of a toroid, but shows you what it's like with some direct light on it, and then basically with light beyond it. So it's fairly transparent. And the reason for that is all of the smoke evacuation equipment for the whole subway system is up there in that upper area. So the whole form is basically a smoke reservoir. So smoke is drawn up, sort of retained in that space, and then exhausted out through this net, basically. So it serves a very pragmatic function of concealing some equipment behind it. But just to show you how this is done, it's a very lightweight cable net. It's all made off-site, and it comes to site like a great big carpet. And one end is attached to a temporary ring which is hoisted up. Cables are then transferred to the fixed ring, and then tensioned down to this first floor slab. So it's a fairly simple net. Only took about a week to install the cable net, and then took about 4 weeks to install the panels. But they're very transparent. Again, like if you walked up to them, you could look right through it. But the material is what's called an optical aluminum. It's a very thin aluminum. It's about the thickness of a piece of paper. It has sort of an very finely embossed surface on it. and it's about 96% reflective. But again, it's a reflectivity that is diffuse. It's very diffuse reflectivity. And that very thin aluminum is bonded to conventional aluminum and then perforated. But what you see here, and this, you can see this better in the morning and in the afternoon when you don't have a bright source of light directly overhead. But what's happening is here, this is actually a cloud, these are clouds, and that's the sky beyond. So going back to what I was explaining before, it's what happens here optically is you've taken a view of the sky, and you've basically folded that view into the building. So this is not transparent, this is an opaque surface, but what you're looking at here is in fact the sky that's back up over your head. So you're basically just collecting that information and bringing it in and letting it be there. You can watch the cloud move around, but it's, again, something that's seen certain times of day when the light levels are a little bit lower. And then I'll just finish on this project, which is at Stanford, but an idea for a little amphitheater, an old amphitheater on campus, and how we were asked to think of a way of how you might provide cover or protection for this amphitheater for rain and sun and control the environment of the amphitheater. So the amphitheater was right in the Olmsted entry to the campus. So here it is. It seats about 8,000 people, and it is about redoing the stage and bringing it up to sort of current standards. But it's always been used for graduation ceremonies and very famous rock concerts with the Grateful Dead and all those things, all those good things that happened back in the 60s and 70s. And then this is it. So it's trying to figure out how to sit something very lightly in the landscape and take advantage of the fact that you have this tree, this shaded area surrounding it. So there's a lot of cool air below the trees, and how you draw that cool air down into the bowl and then draw it back out. So it creates this almost like natural ventilation system. So working again with Schleich Bergerman and partners, coming up with this cable structure and fitting it in so it sort of feels like it's part of the landscape. And it is retractable, so it can be covered at certain times or kept open. And what you're looking at is the cable is relatively small. The cable's only about 1 inch, but it has about a 5-inch high reflector on it. And it's done for a couple of reasons. One is this particular amphitheater faces due south, which is not the ideal orientation for an amphitheater because you're looking into the sun. So we wanted to provide something that could, from some angles, overlap and provide some shade. But again, this is reflecting the north sky. So you're getting a superimposition of north sky image against south sky image when you're in the space. So it would happen at certain times of the day that you would see sunset in these bars, and you'd see a different color sky behind it. So it's just a way of trying to combine those fields of information in it. And this is sort of how it works. But again, these are these engineers. We've worked. We have a small office. We're about 18 people, and then we work with the same engineers and the same mechanical people called Trans-Solar Engineering from Stuttgart for many, many years. So it's in a way it's like an extended office. And we've worked for so long with each other that we try to collaborate on every project. So anyway, this roof covers, obviously doesn't cover the whole audience. We were asked by the president to cover up to about 3,000 people, which is about the undergraduate class, so that they could have special events for an individual class in there. So, but I think in a way it's trying to, it's other materials. I think I've tried to explain, working with glass certainly, but metals or fabrics, other materials just have a certain sensitivity to glass. And one of the hopes here is this idea that you read, because it's lower than the trees, that you actually get the image of the trees sort of projected on the top of the canopy when you're sitting below it. So you sort of have that feeling to it. So in a way, again, trying to make nature something which is a little bit more intimate to your experience of a place. But I will leave it at that. But thank you very, very much for your attention. Happy to answer questions, yeah?
So Jamie's happy to answer any questions about that. In the back.
All
Your
of
first building, your prison block, you said you used a graphite mold.
Yes, right.
How long did the graphite mold last? Or how many castings?
You can make, if you're careful, I mean, obviously it holds its heat. Generally, when we're doing a project like that, you would make 3 or 4 identical molds so that you can actually, fill it with the glass. Takes about 4 or 5 minutes to fill the mold with glass. Then you have to let it sit for a period of time, just dwell in the mold to draw off all the heat so the glass sort of becomes more stable and doesn't deform when you demold it. So you have 4 molds, and usually, it's maybe 15 to 20 minutes by the time you pull the first one. Then you bring that mold to the front of the line again and re-pour it. And out of a mold like that, that's a fairly simple mold, and you're casting it, and then the end of the mold comes off, then you're pushing the glass onto these steel, similar shaped forms that restrain it when it's in the annealing oven, bringing it down to room temperature. So there's a bit of abrasion from moving the hot molten glass off of it, but you can probably get in that instance maybe 100 pieces from a mold, without much recognizable wear. If you had obviously a little more complex pattern or something, you would get fewer. But because it's all sort of linear, and it was designed to slide out of the mold, it didn't wear as quickly as some other molds we've done. But it's a liquid material. You can cast it, you can centrifugally spin it. You do a lot of times spin shapes with the glass.
How did you make the graphite mold? CNC milled?
It's all CNC milled, done by a company actually outside of Philadelphia that likes working in graphite, which is really messy. As you can imagine, you walk into their shop and it's like a skating rink, and it's all like graphite on the floor and it gets on everything you touch. So it's pretty.
Do you remember the company name?
They are called. Give me a minute. I can give you their name. Yeah.
Mark Simmons is doing a studio, and I think
Yeah.
it's glass.
Yeah, we're trying to make
Yeah, they're making
a glass block to make a facade.
Yeah.
We're actually in that process trying to figure out the mold.
Yeah, there are a couple. I'll give you their name. I don't mind giving you their name. They do a lot of the work is done for the nuclear industry, right? I mean, the graphite's used for electrodes, and it's used for glass furnaces. They're made out of big carbon electrodes. So there are very few people that like to machine it. But it's graphite under super high pressure with bonders in it. No, it's self-lubricating, and the heat doesn't have anything, won't affect it at all. But it's just the tooling. You have to have all vacuums all the time, like sucking the stuff out. It's very, very invasive. I mean, if you're going to do something, I would say just get flat block and sort of figure out what you're going to do with it, with as little work to it as possible. It's not easy to machine. Or you want to do it in a machine shop where the person knows ahead of time it's probably going to ruin the machinery. But
Okay, no more questions for Seven Studio.
Has there ever been a time where life presented itself to you as unexpected or
yeah, that happens a lot. I think you try to be. It probably really didn't show that so much, but we do a lot of modeling, physical modeling. We do a lot of the analytical modeling, but the great thing about light is it's scalable. So you can make tiny little models. We make small models out of thin glass and chemically machined stainless steel. So we do a lot of models, at all different scales, and then study those in terms of what happens under daylight conditions. And I think what we do is you obviously try to anticipate things and eliminate perhaps more unwanted effects, certainly. And then the hope for fact is that you will get unknown things, but that they're, sort of contributory to a more positive reading of light rather than something that's sort of like undermining the intent or the idea. But we do a lot of physical studies. And then, then we're very close to the manufacturing, so we're actually seeing it as things are being made in stages. So you can always do some correcting if need be through the process.
It was interesting. You didn't show any simulation.
Yeah, I just had a couple in there for like the Sky Dome, but yeah, we do that. We do that all the time, like for the those louvers in Israel and stuff. We do full three-dimensional modeling as well. Yeah, digital modeling. Yeah, exactly. But I have to say that intuitively, a lot of it's just intuitive too. You're just working with it and getting an idea of what can happen or will happen over time.
Is there an equivalent of the concept of half-life as you say in physical work?
An equivalent of what? Cast?
Half-life concept, like where there is life, but it's not completely, completely illuminating the area, but you still can feel that there is life. I'm just talking about
You mean lower levels of light in general, or I mean, you're using a term, what, half light or something?
Yeah, it's not from
Yeah, well, I mean, it's remarkable how little light you need to see things. We've done, I didn't show it here, but we've done a project in Washington, D.C., which is it's like a 140-foot high atrium. It's like 60 feet long and 8 feet wide. And when it was designed, the architects sort of, I guess, convinced the owners that they would actually have daylight down inside this atrium space, which obviously is not possible because you have maybe 5 minutes of light at noon and that's it. But we then took a device which is called a heliostat. Heliostats are devices which track the sun all day or moon, and they project that beam of light to a fixed target. So basically on that project, we took a mirror, it's about 5.5 feet square, so it's just about this big, which you might compare that to, say, an average window in any building. And we took that mirror and then a group of secondary mirrors, took the direct light, bounced it off secondary mirrors, and then sent it down through a cone. The cone is 8 feet diameter at the top, 18 inches at 120 feet down. And there's a prismatic glass on the sides of the cone, so when the light hits the cone, the glass is constantly harvesting it and projecting the light horizontally. So instead of having direct light just boom down the bottom as a spot, it's 10,000 lux, which is, you can't even look at it, it's so bright. You actually take that same amount of light and then just spread it out over literally 140 feet of wall in the space, and it's perfectly lit. You can walk in there and you'd think it was as brightly lit as this, but it's actually no more light than an average window. And that's just a good example of the fact that we really don't know how to use daylight. There's just years and years of talking about daylighting and light shelves and this, that, the other thing, but it's not really being used very effectively, actually. I mean, if there's much, much better ways to distribute the light, you could get away with, we're actually trying to design some windows that are, the actual window aperture is relatively small, but that light is then pushed across one of these optical aluminum surfaces. So the actual energy coming into the room is little, but the source of light appears to be, maximized, in a way. So there's just lots of little things like that that could be done that are more effective, basically.
A lot of the way you describe how light is collected reminds me of how insect eyes work, with a lot of radons and
Right. Multiple, right.
Yeah. Do you ever get inspiration from nature?
Well, no, I think of our work as sort of, and I hope I sort of communicated that a little bit, I really think of our work as a way of reconnecting people with nature in an urban environment, like the Dome in New York. I mean, we all have a sense of connection to nature. We feel like we've lost it oftentimes in an urban environment, but you can set up these opportunities where all of a sudden, okay, this is something, I sort of feel connected to this in a way that's maybe in an unusual circumstance, but it's not just an individual connection, it's sort of a collective connection. And I think that's the important thing, is you're trying to do things which we share in an urban environment. We sort of share this sort of, awareness and sort of pleasure or wonderment in nature, I mean, whatever that vocabulary may be to describe that. And it's something we lack oftentimes. So the work is sort of geared towards how do you find methodologies to reveal those things in a permanent way. Not a recording, but in a permanent way. Well, sure. I know Terrell and some of the, Irwin. I know those guys pretty well. But certainly, everybody's sort of tracking, I think, on a very similar, reverence for light and its potential to sort of change our, perception of space or perception of life in a way. I mean, some people are getting into like a very highly spiritual approach to working with light. But there's no question. I mean, what I've tried to do. I was doing all those film projects early on, and that was about light. It was about recorded information. It was about trying to connect you to things in nature. But I was a little bit, I guess, uncomfortable with having an audience that's like a gallery audience. You have a very limited number of people. It's a very preconditioned, world basically. And I was actually trying to figure out how do you do things that are just there, but they carry forward a lot of the conceptual basis of, say, an artwork, but they're experienced by anybody. Anybody who may never set a foot in a museum or gallery their whole life, but they sort of see something, and it has a moment of meaning, in terms of their activities, for the day or for the week, whenever they pass through the space.
I really appreciate the simplicity of the meaning behind it. It's so elegant. I guess from the technical and scientific side, I'm curious to know if you all hold patents or have any patents.
No, sort of reluctantly, we have none. But sort of, I don't know, we've always thought about that. For better or worse, we've always just tried to learn from one project and then do the next project, and it becomes something different. But many of those projects could be a career in and of themselves, just pursuing windows without a view, that you can spend the rest of your life trying to do that, and it would reveal probably all sorts of really exciting things. But I think for us, each opportunity, either collaborating with someone or project that's brought into us directly, we just try to use that opportunity to explore an idea that may have surfaced in an earlier project, but we realized it wasn't the right time, and then this project does seem to be the right time, and how do we make that work? Or the particularities of a project give you the challenge and the answer simultaneously, right? And you work towards that. But I think the important thing, something you said, is that I began working in glass at a time when there was very little vocabulary in terms of how you work with glass, and very little knowledge about the strength of glass. And a lot of our work, which I didn't even show this evening, was about, this is in the 80s, exploring the structural properties of glass and tensile systems to work with the material. And I've always worked against the grain of many architects and engineers who have exploited cable systems and bolted systems where the glass is really, you're setting up this fairly intricate and very overt structure to achieve fixed points in space to which you attach transparent material. So the glass is actually has no function other than keeping out the weather, and you're sort of want to be mesmerized by the complexity of the structure or the cable details or all that. And we're sort of approaching it from a completely different direction, where you want the structure to be really, really quiet and secondary. It may be a tension structure, but we'll develop the fittings and things so it's very quiet, and that you then are more aware of what the actual phenomenology of the glass itself is. So you're actually, just the priorities are very different. Like, you want people to read the glass rather than, look through it. And that's a huge dilemma with glass and transparency. I mean, transparency is a really curious word. Sort of a,
Excellent extension of Friato's work.
Well, no, Fry, obviously love his work, but I think there's a lot of things, like even with Peter Rice, there's a lot of things where, the big, cast steel fittings and all that to make these big cable systems, it gets, not Fry Auto's work, but if you look at a lot of fabric cable structures today, there's so much muscularity in the cable systems to hold up the lightest piece of material, and it's like something's wrong, basically, right? And that's a little bit like that project for Stanford. You're trying to do something there, and when we're lucky there, because they're not very high winds, so you can get away with some lighter, structure, and then you can retract the thing if it gets too windy. So you can actually do a fairly lightweight structure and then not have the mechanical structure overcome it.
How has technology changed your practice? So from some of the very early projects to later, being able to do simulations and being able to maybe furniture design to be able to keep an idea of the exact light refraction that.
Yeah, well, no, we definitely try to keep up with things, and certainly like that cable net is highly complex geometrically and mathematically. So yeah, we have to keep up when doing that type of a project. So there's certainly that type of digital upkeep, let's say, that we need to do to achieve certain things. But I think on the other end of technology, it's just the advances in the materiality and capabilities of different types of glasses and different types of steel and different alloys. Like a lot of these things that are built for blast resistance use these very eccentric alloys of steel, and it wouldn't have been available 10 years ago. But anyway, yeah, I think we try to keep up with that certainly on all of that. And then glass, is very, it's really advancing very, very quickly, and it's as you well know, getting thinner and thinner and thinner, and you can buy a roll of a mile of glass. You can go out and order it, and then the question is like, what do you do with it, and how do you structure it? And that hasn't been answered yet. It's not really being manufactured for that purpose, but it has the potential to be used for that purpose. I mean, continuously.
So I have a question. So a lot of the work that you showed were collaborations with other architects, with the exception of, I think, the project in Israel. Were you
Right.
the architect on that project?
Then we're the architects for that project, yeah. So we have a separate practice. So in some instances, we will take on that role, as design architect, or do the whole thing if it's a small enough project. I don't think we want to get into doing like whole tower construction and all that. I mean, we have an office, like I said, it's like 18 people. We have very good communications and skill sets with our office. And I think we see a problem of trying to go out and do more. I mean, we have very, very productive and fruitful collaborations with others, and we try to find those synergies and bring to the equation what we can bring. But I don't ever see us sort of trying to become an office that tries to go after huge projects. I mean, I think we are very good at doing in-house, smaller scale projects we're very happy to do, and bridges and spaces between buildings and canopies. And there's a whole field of beautiful projects that we're very happy to do. But I don't see us trying to jump into doing whole buildings. I mean, maybe chapel, or we do some bigger buildings, but it's not our goal, I don't think.
I might need a new window in my house.
Or maybe not that. No, but something has a challenge to it, and sort of aesthetic goal. Okay, well, thank you very much for coming.